Now we'll look at an Excel example for the multinomial population goodness of fit test. So let's look at problem number 3 from page 477. Okay, so during the first 13 weeks of a television season, the Saturday evening 8 p.m. to 9 p.m. audience proportions were recorded. Okay, it's 29% for ABC, 28 CBS, 25 NBC, and 18% independent. New sample of 300 homes were taken 2 weeks after a Saturday night schedule. And then in that sample, 95 homes were watching ABC, 70 CBS, NBC is 89, and independent is 46. So now we want to test with significance of 0.05 whether this sample is consistent with these percentages that we previously recorded, or is it different? So that's the problem. So let's go back to Excel. So the population here is the TV network a household is watching during 8 to 9 p.m. Saturday. Now, with subscripts 1 denoting ABC, 2 CBS, 3 NBC, and 4 independent, now we can state the hypothesis as P sub 1 equal to the probabilities as given in the problem. 29% P sub 1, 28% P sub 2, 25% P sub 3, and 18% P sub 4. Okay, and these percentages should sum to 100%. So here if we can set up the null hypothesis probabilities here, sum this, and that should equal 100%. We have to verify that. Then the alternative hypothesis is simply at least one probability above is not as stated. And we want to test this at 5% significance. The frequencies for each of these 4 networks is given in the problem. Okay, the sample 95, 70, 89. So we have 95, 70, 89, and 46. And of course, when you sum these frequencies, it should equal the sample size. When you take the sample size and multiply by the probability, so n times p sub I gives us the expected frequency. So you take the sample size, and that should be absolute referenced. So we need to press the F4 key, multiply by the probability. Now that's our expected frequency. Let's put the border back. And the chi-squared value, okay, the formula for chi-squared is right here. So you go the observed frequency minus the expected frequency, and you have to square that and divide by the expected frequency. Copy that. Put the border back. Now sum that. That sum is our chi-squared test statistic. Okay. The number of categories we have, so we can use count A of the categories. If you simply use count, that will only count numerical values. So when you have non-numerical values, you must use count A to count the alphanumeric categories, which are 4. the degrees of freedom is k minus 1. And the p-value is chi-squared chi-sq.dst.rt, and the chi-squared test statistic value, comma, degrees of freedom. That will give us the p-value. So the conclusion is since the p-value is greater than 5%, do not reject. Do not reject H sub O. So the interpretation is we do not have sufficient sample evidence to conclude the proportion of viewership for the 4 networks is different from what is stated in the hypothesis here. If we conclude otherwise, then the probability we are wrong, that is type 1 error, is 7.6%.